I guess, okay, number one, I never researched it myself. And number two, nobody ever shared that with me. Are you kidding me? That Pythagoras wasn't the first to come up with that? It was developed long before him? I'm like, so the guy comes along, takes some, you know, was he a rich guy? And he bought the rights to the theorem? No, I'm not. I'm kind of joking, but I'm not joking because I'm like, okay, you know how people, well, in history, it's been so long ago, we just attribute it to him, but he was, maybe he was just, the guy whose company used the theorem a lot, to, develop like, space technology, that, okay, so from 3 on.
I mean, it's just like how everybody thinks that Sydney is the capital of Australia when it's not.
Yeah, we don't even know who Sydney is. Okay, so so from 3 on you said you were struck?
Yeah.
Okay, so find the polar form of the complex number where the arguments, okay, so 3i, where is that on the real and imaginary axis? Now that's the same thing as 0 plus 3i.
That would be going 3 up.
Correct.
On the y.
Correct.
On the I, I'm sorry.
Yes, on the imaginary axis, it's right there, okay? So, find the polar form of that. Well, the polar form of that would be, we need the radius, and we need the angle measure. So, all we're doing, we need this distance, because that's the radius, and the angle that you're facing. So, as you rotate that over,
Alright, well, we know that the r is going to be 3, of course. And now we just need to...
So if this is 0 on the right,
okay,
what's at the top?
Well, there won't be anything, will there?
Wouldn't that be pi over 2?
Oh, yeah.
Now this is an actual... Right angle. This is a real coordinate, okay?
Okay.
Not a complex number. So this isn't the correct answer. Okay, but it's like the correct answer. The correct answer would be 3, and then we would have what?
3,
cosine.
Right, the cosine.
It's bad looking 0.
Wait, it's not supposed to be 0.
No, it was supposed to be the letter O, but it's really horrible looking. Okay, I mean, it's demeaning to all letter O's. Okay, so cosine pi over 2 plus I sine pi over 2. Okay, if you look down here like at question 13, it's in polar form.
And we just have to go backwards.
And you're just going backwards, okay? So that's all you're doing is you're identifying. So even though this is the real coordinate, the imaginary coordinate looks kind of like this. And it's polarized. If you look at it through polarized lenses.
Or Polaroid.
Yes. Snap, and then it develops. Over time.
Okay. Probably don't even make those puppies anymore, so.
I highly doubt it, but,
I mean, that's a blast from the past.
Amen. 2 plus 2i. I do miss these little sessions where we record them and put them online, because you are a funny guy,
I mean, I come here whenever I can. It's just...
Yeah, you need to come more often. Yeah, so there's 2 plus 2i. I did it in blue. Okay? Okay, yes. So plus 2i. All right, this is question 5. All right, so
we have to go.
We need
2
that
to the right.
Yeah.
And then 2 up.
So we've got this little triangle. We need the radius.
Yep, and that would be the let's see, the horizontal part's going to be 2, of course. And then the vertical part, the vertical leg, is going to also be 2.
Yeah, so use your Pythagorean theorem, unless you know that that's a 45, 45, 90, right?
Yeah.
Yes,
because it's S radical 2 for those things.
Yeah, that's true. That's true. So if we use Pythagorean theorem, or we use that little geometry trick, we would know what?
would be 2 radical 2.
2 radical 2. Okay, so we got that. Now we need the angle.
All right.
Good morning, everyone.
Good morning.
We have a bake sale going on this morning by
do?
Door 1. National Honor Society is sponsoring a bake sale this morning.
Yeah.
And
Tangent
they are
inverse,
located at door
opposite.
number 1.
Opposite
Thank
over
you.
adjacent. Opposite over adjacent, right? So what do we got there?
That would be
Yeah, get out one of those handy dandy calculators if you don't know it off the top of your head.
okay. Okay. That would be 2 over 2, and then 45.
45 degrees, thank you very much.
Or 50 gradients.
Let's not go there. The children will get confused with that. That's true. Seriously. You really want to confuse people. Okay. All right, so 45 is the degree measure. So we've got 2 radical 2 cosine 45
Yes.
plus I sine 45. And that would be your answer for question 5.
All right.
So do you kind of get the idea
Yeah.
of what we're doing? We have to plot the point
Really.
and find the triangle.
And then do the magic.
The magic, yes, also known as the Pythagorean theorem and inverse tangent,
Which was not his theorem.
which was not Mr. Pythagoras' theorem.
Just so a theorem that helps you find the hypotenuse or any side of a
Yeah,
right triangle.
exact-
But, I mean, we
Yeah,
can't
yeah,
name it
true,
after him.
True,
So,
true. We should try to figure out who he stole it from.
And it's probably going to be one of those ancient mysteries. So that's
Yeah.
never recorded. I mean,
I know. Okay. He probably beat somebody up in a cave somewhere, and stole their theorem, and then tried to claim it as his own.
oh.
Well, we probably better not,
But of course, I don't know. I mean,
Who
was he
knows?
Greek or Roman?
Pretty sure Greek,
Oh.
but I could be
The
wrong.
Romans were opposed to things like that because they viewed that as barbaric. But the Greeks, I don't know much about them because I never took
Yeah.
the language. But
All right, so next on our agenda is what? Do we need to go the opposite direction?
the opposite direction. Yeah, let's do number
Let's do number 11. Okie dokie.
11.
So question 11 says, oh, I better go back and see what the heck find the polar form. Oh, well, they gave me a picture instead of me having to draw the picture. All right. So that's a 30-degree angle.
30, 60, 90.
So it's in polar form.
All right.
Well, don't I just have to look at the radius and the angle? So wouldn't this just be like 3 parenthesis cosine what?
That would be. Well, the radius would be.
Well, we know the radius, right? It's 3.
Yes.
And then we know that the angle is 30.
30, so.
So what's the other part?
Plus sine.
I sine 30.
And whenever we do these, we always have to put y in front of the sine because it's on the imaginary axis.
Yeah, yes, you're right. Now, 12. I just want to do 12 because it's more challenging than number 11.
Well, at least we know that
But what's the radius?
it is 4.
4. Okay. Cosine. What do you get? Don't put 45.
Oh, shoot.
Ah, so I gotta go all the way around
Yeah,
there.
it's in a completely different quadrant.
Yeah, so what angle should I use?
Well, let's think about this for a minute. It's 180
Yes. 180 plus what?
plus 45, which is 225 degrees Fahrenheit.
Fahrenheit? Yep. Okay. Definitely boiling that angle.
Oh, wait, I
It's
know.
very steamy.
Oh, I know.
See the heat rising off of that one.
That would be 107.222222222 degrees Celsius.
Man. cooking up a storm.
Yeah.
Time to throw in the pasta.
Yeah.
Now, so that was, as tough as that one got. All right.
Well,
That should be enough for today.
All right. Thanks for all your help, Mr. Stale.
No problemo.
I mean, I'll come whenever I can, though.
Nice,
Lately,
yes.
it's just been kind of rough.
Busy guy, huh? Well, get back as soon as you can.
I will.
Love these little sessions,
I'll
man.
try to get here on Thursdays and Fridays.
All right,
As long
nice
as
job.
I'm not called to duty.
Yes. You play that game too?